Okay guys, welcome to the stream. Great, so I've got people viewing, I think. Can you guys hear me on the chat okay, on the audio? I'm always paranoid about bad audio. I've had problems in the past where I've accidentally plugged into the wrong thing. Okay, let's get underway. So, looking at ExploitDB, I've had just a quick skim over the directory structure. So I figure we'll go for some Linux local. Let's just so 442 C files. Let's just have a quick look. I haven't looked at the code, so fixed size buffer, some shellcode. Nothing really there. I mean, obviously you'd want the prototype of main to be correct. It's sort of not very well written, but yeah, so yeah. Shellcode, some assembly. That's not the preferred way of doing. Doesn't check for null pointer from a malloc failure. That's okay. Free buffer. Some so there's a bug. Obviously, they're showing. Oh, that's interesting. They've got a pragma, a Windows thing. Not quite sure why it's on. This is sort of odd. Looks like it might have been some Windows code that was ported to Linux. I'm not quite sure. Generally, you prefer to put. Well, main takes a specific prototype. It's actually not. Well, it might be ANSI actually. So if you don't declare it, but it's not nice. You could probably follow symlinks here potentially. Let's have a look. Exec LE. You don't see that too often used. Bin. Clearly there are path issues, but am I not reading this correctly? What exactly is that? Local root for HZTTY. So there's shellcode, local root exploits. Do you have to compile it? So let's have a look. HZTTY. This is sort of unusual because it's I'm not convinced this is actually. This looks very odd. I'll tell you that. HZTTY. It's running from. It was running from a. I'll just go back to it. It was running from the local the current directory. So is HZTTY compiled? Has shellcode here. Equals ret. Has a fixed size for the stack, so I don't think this will even work with randomized stacks, to be honest. But anyway, you know, I think that one would definitely need to look at to see that if it's still valid. This is better coded. Let's put it arch. Doesn't check for a failure of that set RE0 or maybe I'll just document. I won't document this yet. I don't think they're that important. Memmap. Who wrote that one? Local exploit. Stack top x86. That's assuming a non-randomized stack base. So probably won't work on modern stuff. I'd be curious if any of that shellcode actually works. Okay, I'm going to try something really stupid. So grep minus r mem set It was worth it. It was worth a shot. Usage RV0. So this particular, there's a bug here that it will there's a null pointer dereference when argv0 is null. System ago. That's surely not a good thing. Go. Well, do system. Very annoying code. This has a null pointer dereference for argv0 again. This is awful code. Wait for connection and send overflow. Get shell exit. I'd be really curious if these if the shellcode actually works. Maybe if that's an off by one, maybe. B0, you don't see that often, used too often, no error checking. Close. Print E. sig action, etc. So I just got asked a question, the implication of not checking for null RV0. It's not really a useful bug, but generally it'll just cause a segmentation fault if you run it. If there's some sort of printf or some operation on RV0 and it doesn't check for null. So not a useful bug in terms of exploitability, but I mean, I consider it a bug. Certainly some of the bin utils, some of the core utils code checks for RV0 being null and does appropriate things with it. So in my view, not useful, but I mean, you're not meant to be able to crash it, via calling it in a certain way. Okay, so got a couple of reads. Okay, I think I'm going to look for I think I'm going to sort of stop going through the code so much, and I'm going to look for anywhere that's network access. So I'll grep for either read, receive from. Okay, I don't really want, so look, read, receive, nothing useful, read, receive, receive. I don't want to look at Python. Okay, there is a bug here. It's a tiny bug. So I'm looking for network. I want something a bit better now than okay. Let's have a look. Receive from. RBuff, which is presumably receive buff. Okay, it doesn't use it for anything. Receive. Read. So there's potentially a non-null terminated one here. No, so they got out of that. Oh. This almost this is it's pretty funny. This almost I almost missed this, to be honest. This is pretty classic. I almost missed it. Um, it snuck in there. So GC delay -1. Yeah, that's a pretty funny bug. I don't even think this is. Who knows if this is going to work? That's a pretty funny bug. Yeah, you do see those occasionally. You do see them occasionally. Just typos and stuff like that. Here we go. Return real file handle length. So you can already see that there's potentially integer overflows with length. Let's get an RV to get length buffer. I'm not going to look at it too much more because it's doing files, and I'm not really keen for a file. Receive. So reply. Presumably it's a char array of some kind. Reply 2000. Let me just check. Receive the man page just to be sure. Receive. That's good, yeah. So there's a not null terminated again. Sock receive. So this actually does null terminate, which is good. However, this so yeah, it's such a silly bug that it's clearly a bug. Okay, I'll just write it down. It's an off by 1. So R bytes is the number of bytes read. So, example, if len is 1024, then R bytes returns if read. Then off by 1 should be dest R bytes minus 1 equals 0. Silly bug. It does happen though. I mean, you do see these types of bugs. I mean, off by 1's are sort of a pretty classic. Someone just got here. I'm looking through ExploitDB and just initially I had a quick look at some local exploits one at a time, just to get a feel for the code. I noticed some of the code was using some sockets and was receiving data across the network. So then I thought I'll just focus the audit, for now at least, on anything that receives or reads network traffic, and then see if there are any bugs associated with that. Effectively looking at a malicious server of some kind that that ExploitDB is attacking, and then can that malicious server cause a client-side bug in ExploitDB. Okay, so the question is this a bug? Yes, it's a bug. So just a little bit more detail about that. Oh no, no. Well, okay. So it looks like they haven't. I mean, it's not strictly a bug, because sock receive is doing -1. So all you're looking for is one that doesn't do a -1. It all does it. Okay, strictly this isn't a bug because of the way it's called. But really, I would consider it as a bug. I mean, as a dev, you would never, that would never be acceptable, really. Okay. So next one. Receive. Maybe it's read. To send and receive. Okay, it doesn't matter. Receive, read. I mean, just a comment to say, yes, it's not strictly a bug, depending on how it's called, but I mean, as a dev, you would refactor that. That's, it really violates the basic principle that a length is a, a pretty well-defined thing, and to add one to it, in my view, I would consider that would need to be fixed. Well, we'll ignore that one. What have we got here? Okay, I'll just leave it. For there's some funny bugs that have been here. I think this is the funniest of the day. This one here. I'll just leave that there for people to watch. Yes, Printf. Let's go to the next one. Receive. Man, 4096 plus 1, so it only has to use 2 pages. It's I would consider this undesirable code for the fact that as a minimum now it needs 2 pages. But it's a sort of a, I think, 4095 plus 1, or 4096 minus 1. Of course, malloc can return a null on fail. Okay, buffer. So there might be some bugs here. It's using sprintf, no error checking. Nick, so where does Nick come from? Yeah, this is a pretty funny one. It's terribly styled code. Okay, so request. So can you make so which one's this one? DOS. Exploits. I think it might have been my Slack. Someone asked if that beeping was. I think it might have been my Slack. I should turn that off. So sorry about that, guys. Let's have a look. I think I'm on Linux. Am I on Linux? .c. Is this a shell script? That's not great. So 789. What was that? 789. $78. So is it meant to be a new line here? So user ETH0. No, so it's God, I'm just trying to remember IRC now. Let's just put a I don't even know how any of this compiles. I can't remember for sure. It's been so long since I've used no, I think it's just you can clearly tell that this has been tested, can't you? Let's just have a quick look. Clearly been tested. Someone's clearly tried to compile this. Okay. Okay. So 89 host IP I might have to let me have a look at this. Okay, so I have to so that is wrong for a start. This is meant to be doesn't have a timeout. Okay. I'm starting to lose interest in trying to do this. I just want to trigger this buffer overflow and then I'm done. Okay. Attack is success. Okay, so where did I go wrong? Nick, wait up. 13 has up to 130,000. What have I done wrong? So it's got arg3, 1, 2, 3. Okay. One more time, and then I'm moving on. Segmentation fault. That was so stupid. I have no idea why I spent that time doing that. Okay, it's sort of silly. That was a complete waste of time. Okay, so let's keep on moving. This is oh yeah, what file was it? Receive, read. Read, what file is this? Might do Python. Receive, oh, read. Okay, the next one. Receive, read. Here we go. Another one. So this I think is this. I think this is basically by the same. Yeah, by the same people. It's it must be a variant on that bug. Only 598 files to go, or minus 39. But we won't do any of the Python or the... Okay, so... this is not null terminated again. So... buffer... not null terminated. It's funny, they use SN Printf further down below, so they are aware of more bugs. SN Printf. Let's go to the next one. Next one. sock receive. This is the same coding style as before. Interesting. Look, I'm going to say, look, you know, is it a bug? Three, two, 8, 9. Receive, so 255. This is they thought about it. They thought about it. Like they knew that there was a but you know potentially receive is not guaranteed to be zeros since it's on the stack. Thus, receive may not guarantee to null terminate. It's funny, they thought about the problem, but they just thought the mistake was that they thought that if a char array is on the stack, then it's initialized to 0. Go to the next one. Next one. So this one they did. This is sort of the correct coding style. So they've got their receive size buffer. They've done -1, leaving space for a null termination, and then null terminated it since they're using it as a string. So that's correct coding style, or correct code. And I don't mind that coding style actually. I think it's quite reasonable. They error check. They do error checking on their connections. So that's good. But it'd be nice to find a bug in it because they are so what else can we find here? It's all running out of code. There might not be main. There is a bug, so RV0 is not guaranteed to be a pointer to a string. It can be null. So if you create argv0 as null in something like execve, this program will crash. But yeah, it's not a big deal. Read threads, great. Let's see how they go. So classic mistakes with Pthreads is using non-reentrant APIs. And to be honest, there's non-reentrant APIs are all over the place that that people aren't even aware of. To be honest, when you start working on a code base with Pthreads, it's is it Pthreads? I don't really see any Pthreads code here. No. Oh yeah, there are some Pthreads code. So Pthread create, wait for success. Are there any global variables? They've got the thread args, which is good. Who wrote this one? There you go. We'll skip that one. Read. Go to receive. Receive. We'll just check for read. We'll just go to receives. I'm running. This will take me hours to go through all this code, to be honest. So I don't really want to spend too much time going through everything, to be honest. Some Python. Receive. And this is just the denial of services. This is a very small part of ExploitDB, really. Okay, so what do we got here? So classic things. This is in fact well, I don't think there will be a race here in this particular instance, but the Signal is a deprecated API. You should use SIG action. Resolves a lot of issues. Nothing too much. Could be some bugs here. I don't see if that's null. There could be some bugs with that, but RV0 can be null. Uname. Okay, so this is a simple sort of bug. Let's have a look. Maybe. Anyway, it's getting sort of into sort of a low impact one. What else have we got? Looks like a lot of code. What is this? Okay. Receive message. TCP receive. So I guess this is receiving this is taking data off the network in big endian format, 16 bits, through the sockets. Yes. Oh, is that a socket? Through a stream. This is presumably their own API, their own layer. Conceivably, you could make length high. So if that's 16 bits, you can go to like 65,000 or so. And then length minus, or you can make that low as well, so make it like 3, and then length minus 4, you'll get an Ninja underflow. Let's just Google for length. BER pass. Is this ASN style ASN.1? Let's go to pass headers. Get a tag. So is there anything like int 32? Yes, so in uint 32. Magic modulus length. So this, nope. So it does a check on that. Key size. Well, I'm pretty sure you can get. Let's just say it's not really doing length checks on random len. Or RSA. Okay, so it does a check, length check here. So there is a good bug here now. Yeah, so this is a nice, this is a good bug. So pass crypto info. So there's an integer overflow. I won't go into it too more now. I found a bug. So read 32-bit number on 32-bit systems. Pointer plus v32 will integer overflow and bypass this length check. Oh man. Receive. Okay, I'm thinking that I might wrap it up shortly. Did anyone that is watching the stream have any questions? I'll go through all the bugs again that I found. This is a very small audit. You could literally spend a few days, or going through all the code here. And there's lots of bugs in this code in ExploitDB, without doubt. So for this particular bug, integer overflow, we assume we control RSA info len causing an integer overflow on a 32-bit system where pointers are 32 bits, and then you're able to bypass that length check. This particular bug here, the receive buffer, the char buffer on the stack isn't guaranteed to be initialized to all zeros. So when it receives the data and doesn't explicitly null terminate, the string may not be null terminated, causing random data to be printed and potentially crash. Likewise for this one. This one reads the entire buffer, doesn't null terminate it. This particular one here, these sprintfs, should be using snprintf. So if you pass an argument with a fairly large size, nick comes from one of the arguments to the program, then you can cause a buffer overflow, a heap overflow in this particular case, since it's coming from the malloc. This particular one, well, some might say that it's not a bug. As a developer, I would call this a bug. I think if you change the semantics of a length argument or parameter, then you're always going to have problems. So it writes one past this length parameter to the buffer, and even though later in the code it makes sure that there's that extra 1 byte allocated, in my view, I would consider that a bug, or at least that really bad coding practice. But this particular bug here, receive again, we're not explicitly null terminating the buffer and treating it as a string. In this particular bug here, this is quite a funny bug. It's taking a size of a pointer, a char buffer, and then subtracting 1 to and getting the size of that, when in fact it's meant to take the size of the buffer minus 1. So that will cause all sorts of problems. In this particular bug, again, as before, not guaranteed to null terminate the buffer when it's reading. And then general patterns, lots of stuff. Having a quick look at the beginning assumes the non-randomized stack based. It's making all these assumptions about where the stack is. A lot of code doesn't check for general errors, malloc failures and so forth. A lot of code doesn't check for null, RV0. Lots of unsafe APIs are being used, sprintfs, systems and so forth. Some socket calls aren't being checked. Then we have things like deprecated APIs, for example, signal instead of sig action. So I think that will be the end of the stream. A few bugs, a variety of bugs, a lot of those not null, explicit null terminated strings and buffers. So thanks very much. Go to the Patreon page if you want to donate, but you don't have to as well. I'll just let my lagged stream catch up, and then I'll call an end to the stream. Okay guys, I'll see you next time.